Okay, I'm going to go over assignment one, not assignment one, assignment two. Assignment one is, we've already finished that. So I want to do assignment two for you and help you get the problem statement done. So we're going to go ahead and click on this so we can see that. Go ahead and make this a little bit smaller so we can squeeze it in together. Okay, so this is the problem that we have. Squeeze a little bit more. There we go. Okay, so that's the problem we have. And so um, I've given you a link to this before. I'm going to put this up on the in the assignment one um, page also, where you can download Notepad++ Portable. I think it's much better than using Notepad because it keeps track of the names of your variables. And so once you download it, you'll have a folder like this. Just double click Notepad++ Portable.exe, and it'll open up. Whoa, look at this. Well, that was the answer. All right. All right. So here's the problem. And we have two different kinds of trucks. They hold either 5 or 10 tons, and we're moving rocks, and we not got to know how much to charge them. So the most important thing to do is first break this down into the four elements. So I'm going to come up here, make some space, assumptions, input, calculations, and output. All right, and the first thing you want to do is go get output because output is easy. It says here they want a receipt that will show, and this. So the best thing to do is just go ahead and copy that and paste it into your Notepad++, and then we're gonna do. What I'm gonna do in this one is I'm gonna do a combination problem statement and a human algorithm, and you can do the same thing if you want. I'd like to change the class eventually. Okay, so tons moved by small trucks. So I'm just going to start hacking this down. And tons, oops, there we go. So tons, and then small, and then trucks. So we camel it. That's basically the difference between a problem statement and a human algorithm is that the human algorithm has no spaces in a name, so we'll just skip the step and put no spaces in this. And next we want to do the same thing with large trucks. So again, we'll go ahead and delete all this minutia, and then tons, oops, tons, large trucks. I'm doing camel notation here. So everything is lowercase, no spaces, except for the first letter in every word after the first one. All right, then the next one we have is total tons by all trucks. So let's just make that total tons. And then we'll get rid of that. And then cut this down to money owed. I recommend you do that for each of the lessons because if you copy and paste, then you won't miss anything. So I copy and paste it. This is all I want out. That's what it said the receipt is. So we'll take a look at these and say, okay, well, next thing I want to do is low-hanging fruit, and that's my assumptions. And we look for two numbers, or look for the numbers. There's the number of 5 and the number 10. So we need to put that into our assumptions. Those are what we call constants. They never change. So we'll do weight, small trucks, and that's going to be equal to 5, and then weight, large trucks, equals to 10. Now the nice thing is spelling doesn't matter. With you, especially using Notepad++, if you misspell it, as long as you consistently misspell it, I don't care. Okay, now that we have these two constants, now we have to come down here and decide, are any of these going to be input? So is anyone going to input this information? And it's not true because these are all going to be results of math. So I'm going to copy these, Control C, paste them up here, Control V, and put equal sign space after each one. So once I put that in once, I'll do Control C, Control V, Control V, Control V. And then we start with the bottom math, because the bottom math is the easiest math because it always use stuff above it. So the money owed is how many tons removed times the rate per ton. Okay, so that's what we'll do. So the nice thing about Notepad++ is once I start typing T, and you can see that it gives me a list of all the things that start with T, and we'll select total tons. And then we just simply multiply that, with a star by the rate per ton. Okay, so if we take a look at the problem, we could say, well, we have a $2 rate here, we have a dollar rate here. If we had 5 more examples, we might have a $3, a $2, an $8, $4, doesn't matter. We don't know what the rate per ton is, it's not a constant. We have to ask somebody, what is the rate per ton? So I'll come up here to my input, and I'll start typing rate, and you can see rate per ton shows up. And then I just hit tab, and now I have that. So that's going to be one of my input. Then I move up here and say, well, what math do I need for total tons? Well, if I know the tons of small trucks and I know the tons of large trucks, then I know the total tons. I simply add them together. So again, I'm going to use using Notepad++. I just start typing T, and then I can select, let's do small trucks first. Doesn't make a difference. Small trucks, tons, plus tons, large trucks, and I have that. And then I move up. And it goes, well, what's the math to figure out how many tons were moved by large trucks? Well, if I know it's 10 tons for each truck, if I have 10 trucks, that's 100 tons, right? So I start with the weight of large trucks, and I simply multiply that with a star by the num LG trucks. So I had typed that because it doesn't exist yet. So how am I going to know how many large trucks picked up rock? Well, someone has to tell me that. So once again, that has to be input. So I'm going to come up here, and I'm going to do num. I'm going to say that's the only one I have. So I type that in. I'll make some space for the next one, because the next one is the same. It's going to be, except for small, so it's the weight, small trucks, times the num small trucks. And I guess to be consistent, since I used LG, I'll use SM. All right. And then here, it has to be input, how many they have. So num small trucks, 10. All right, so I have done all the math. And once I know done all the math, that means I am done with the problem. And this is the problem statement / human algorithm to solve this problem. Now, the only thing I want to add is to my assumptions. I need to do scope. So one of the things I could do is only 2 types of trucks. And I'm assuming that. But if I go back to my client, the client said, and I say, oh, so only small and large trucks? And he goes, yes. Well, sometimes we get an extra large truck, and that's 50 tons. I go, well, should the application use that? And if they say yes, I have to change my application because now there's 3 types of trucks, not 2. And that's why I put this into the assumptions. Only 1 contract. So this is just going to be 1 contract where we negotiate the rate and then figure out how many trucks were moved. And what's another one? Rate changes with each contract. So I'm assuming that's true, and that's why we have it as input. But if we went to the person, they go, well, No, not really. It's always $2 a ton, and it'll probably be that way for the next year. Well, then I'm not going to make it an input. I'm going to make it um, a constant. All right. Well, I'm done. This is a problem statement for assignment 2. All right. Now all you have to do, and again, this is a combination because normally the problem statement has spaces in the names, and then the human algorithm does not have spaces. You can do just one, just a problem statement, and take the spaces out if you wish. So this is it. It's done. Now all you have to do is flowchart it and code it, which should be pretty easy, particularly if you work through the lessons.